Welcome back to the deep dive. Today, we're diving into something that feels both really old and super current: kombucha.
Absolutely. That fizzy fermented tea.
Yeah, sometimes called the elixir of life, right? It's gone from this sort of niche home thing to a huge industry.
It really has. And, our goal today is to get past the hype. We've looked at sources covering the whole process,
Okay.
the brewing, why people do it at home, the money, the creativity, and crucially, what the science actually says about the health stuff versus the risks.
So the full picture.
Exactly. We're aiming for that full spectrum view.
All right, let's jump right in then. You see kombucha everywhere now, in every store. So why are people turning their kitchens into like mini labs? What's the big draw for home brewing?
Well, number one is cost. It's
Yeah.
huge.
Really?
If you drink it regularly, those store-bought bottles seriously drain your budget. But home brewing, our sources say it costs just like a few cents per batch.
Cents? Wow. Okay, that's a massive difference.
Staggering, really.
Yeah.
The economics alone are a huge motivator.
But it's not just the money, is it? There's more to it. Control. Customization.
Exactly right. Controls, the other big piece. You choose the tea, you decide how much sugar goes in, which, affects the final sweetness.
Which you just can't do with a bottle off the shelf.
Nope, those are fixed. With homebrew, you want it pannier,
Wow.
let it ferment longer, prefer it a bit sweeter, stop it earlier. That level of control is really appealing.
And I guess it helps if you're trying to replace other drinks, like sugary sodas.
Definitely. Many people see it as that fizzy, sweet-ish alternative that feels, well, healthier.
Mm-hmm.
People report feeling better drinking their homemade stuff compared to, say, regular soda. There's this sense of wellness, maybe less of that sugar crash.
Right. And it taps into creativity too, doesn't it? Like a little home experiment.
Totally. It becomes this small home laboratory. People get really into playing with flavors.
Okay, so you sold me on why. Now how? You can't do any of this without the engine, right?
Go away.
Yes, the Sesso Bay.
Which looks, let's be honest, a bit strange. It is unique looking. Like a pale, rubbery pancake. Or sometimes, like a jellyfish floating in there.
Okay, so appearance aside, what is it? SCOBY. That's an acronym.
It is. Stands for Symbiotic Colony of Bacteria and Yeast.
Symbiotic. That's the key word, isn't it? They work together.
Precisely. It's a partnership. A really neat two-step dance, actually.
Okay, break it down for us. Who does what in this tiny factory?
So first, the yeast gets going. It eats the sugar you add.
Right, the food?
And it produces alcohol and carbon dioxide. That CO2 gives you the fizz.
The bubbles. Okay.
Then the bacteria takes over. It consumes that alcohol.
It kind of cleans up after the yeast.
Huh. Yeah, you could say that. It converts the alcohol into various other organic acids, mainly acetic acid, that's the vinegary tang, and gluconic acid.
And that acidity does more than just taste sour.
Right, more. It lowers the pH, makes the environment acidic, which preserves the kombucha and helps protect it from unwanted microbes.
So yeast brings the fizz, bacteria brings the tang and the safety.
Got it. Now, since it's alive, how do you get one if you're starting from scratch?
Two main ways, really. You can buy a starter culture online. Pretty easy, maybe costs around $7 or so.
Okay.
But honestly, the more common way, the more traditional way is getting one from someone else. Through the community.
Because it just keeps growing.
Exactly. Every time you brew a successful batch, a new layer of SCOBY forms on top. So brewers pretty quickly end up with extras.
Ah, so you have spears to share. That's kind of nice, actually.
It really is. It fosters that sharing culture around the hobby.
Okay, SCOBY acquired, now we brew. This is the first fermentation, F1, the main part.
That's right, the foundation.
Let's talk ingredients. Tea is key. Our sources really push black tea for beginners. Why black tea specifically?
It's mainly about resilience. Black tea can handle a longer steeping time, like 10 minutes, which the SCOBY needs to get enough nutrients.
And it doesn't get overly bitter doing that. Green tea, for example, might get too astringent if you steep it that long. So black tea is just more forgiving for starting out.
Makes sense. And sugar. Lots of sugar, right? Seems counterintuitive for a healthy drink.
It does seem like a lot, maybe 50 to 100 grams per liter. But you have to remember that sugar isn't for you, it's food for the SCOBY.
Ah, right. They eat most of it.
Exactly. Most of it gets consumed during fermentation. The final drink is much less sweet than that initial sugary tea, so don't skimp on the sugar.
Okay, feed the SCOBY now. The crucial step, adding the SCOBY to the sweet tea. Temperature matters here, doesn't it? A lot.
Critically important. Non-negotiable, really.
Yeah.
Hot tea will kill your SCOBY instantly.
Ouch. So room temperature.
Yes, needs to cool right down. Definitely below 32 Celsius or about 90 Fahrenheit. Room temp is safest.
And you don't just add the SQB weight. You also add some liquid, the starter tea.
Yes, the starter liquid is vital. It's just some finished kombucha from a previous batch.
And why is that so important? What's its job?
It's like an immediate insurance policy. That starter tea is already acidic, low pH. Adding it instantly drops the pH of your whole new batch of sweet tea.
Ah, creating a protective shield right away.
Precisely. It makes the environment inhospitable to mold and harmful bacteria right from the start, giving your SWY time to get established and take over acidification itself.
So it buys time. Without it, you're vulnerable.
Very vulnerable. Big risk of contamination without that starter liquid.
Okay, that makes perfect sense. Now the container. Sources say glass, glass, glass.
Always glass. The acids produced can react with plastic, leach chemicals, and definitely no reactive metals. Glass is safest.
And cover it, but let it breathe.
Right. You need to cover the jar opening with something breathable, like a clean cloth, cheesecloth, or a paper towel secured with a rubber band.
Wait, I thought paper towels were bad.
Good point. Actually, yeah, maybe avoid paper towels. They can sometimes disintegrate if they get damp. A dense weave cloth or coffee filter is better.
Got it. Keep flies out, let air in.
Exactly. You need airflow, but you really want to keep out fruit flies. They love kombucha, actomilky, I think they're called sometimes. Little vinegar flies.
Okay. And then stick it somewhere dark and stable temperature-wise.
Yep. Dark place, consistent temperature, somewhere between, say, 19 and 25 Celsius, 66, 77 F is ideal.
And then we wait. How long? 7 to 10 days. How do you know when F1 is actually done?
Usually 7 to 10 days is a good ballpark, yeah. Visually, the liquid might look a bit lighter, more golden. You should see a new whitish or creamy SCOBY layer forming on top, maybe some brown stringy bits, that's normal yeast.
But the real test is taste.
Taste is king. You have to carefully take a sample. It should taste noticeably less sweet than when you started and have pleasant tartness, a bit of acidity.
So if it's still super sweet,
let it go longer.
and if it tastes like straight up vinegar.
You went too long, you missed the sweet spot. Advanced brewers might use pH strips, aiming for maybe 2.5 to 3.5.
Okay. But what if something looks wrong? Like really wrong?
The big red flag is fuzzy mold. Blue, green, black fuzz. If you see that, unfortunately, the whole batch is compromised. No saving it.
Ugh. Toss it all and start over.
Have to. Clean everything thoroughly and start fresh with a new SCOBY and starter. Hygiene is paramount.
Which brings us to managing all those extra SCOBYs you mentioned. The Scoby Hotel.
Yeah.
Sounds cozy.
It's less a vacation spot, more like a life raft or backup storage.
A life raft. Okay.
It's just a separate jar where you keep your spare SCOBY layers submerged in some finished kombucha or fresh sweet tea.
So it's insurance in case your main batch goes bad.
Exactly. If your main brew gets contaminated, you have backups ready to go in the hotel. You just need to feed them occasionally, top up the liquid to keep them healthy. And it's where you get SCOBYs to share.
Some people end up with huge hotels, right? Like kilograms of this stuff?
Oh, yeah. They can get quite large over time if you keep adding layers.
Okay, so F1 is done. We've saved some starter, maybe put a SCOBY layer in the hotel. Now, many people do a second fermentation in F2. Why bother?
Two main reasons. Flavor and fizz.
Ah, this is where you add the fun stuff and get serious bubbles.
Precisely. You take your finished F1 kombucha, pour it into airtight bottles.
Airtight is key here, right?
Yeah.
Pressure-rated bottles.
Absolutely essential. Swing top bottles, the ones with the gasket seals, are ideal because they can handle pressure. You add your flavorings, fruit, juice, herbs, spices.
Ginger, berries, classics.
Yeah, or get creative. Then you seal the bottles tightly.
And trapping the gas is what makes it bubbly.
Exactly. The small amount of yeast still present continues to ferment any sugars from the F1 or added flavorings, producing more CO2. But this time, because the bottle is sealed, the CO2 can't escape.
It dissolves into the liquid.
And boom,
Carbonation.
they get that strong, satisfying fizz that you just don't get in the open F1 jar.
And the flavor options are endless. I saw one source mention banana with turmeric and lemon.
Yeah, people get really experimental. It's part of the fun. But,
Yeah.
and this is a big but,
Uh-oh, there's always a catch.
with F2, safety is critical. You're intentionally building pressure inside a glass bottle.
Right. Sounds like it could go wrong.
It absolutely can, especially if you add a lot of sugary fruit or if you let it ferment somewhere too warm. The pressure can build up intensely.
Leading to explosions.
Bottle bombs, yes.
Yeah.
It's a real risk. People have had bottles explode. So the rule is, be careful. Use proper pressure-rated bottles. Don't overfill them. Burp them occasionally, perhaps. Open briefly to release pressure. And always, always open them over a sink, especially when they're cold.
Open them cold. Why cold?
Cold liquid holds dissolved gas better. Opening a warm, highly carbonated bottle increases the risk of a gusher, or worse, an explosion. So chill them thoroughly first. Treat them with respect.
Okay, noted. Serious respect for F2 bottles. So we've navigated the brewing, the SQOBYs, the potential hazards. Now, the big question, is it worth it for your health? What do the sources, like that Actinska one, actually say about the benefits?
Right, the critical assessment. Well, the potential is there. Fermentation definitely creates live microorganisms.
Probiotics, like lactobacillus, bifidobacterium.
Exactly, those kinds of beneficial bacteria, plus yeast like Saccharomyces. So yes, it can contain probiotics that might positively influence your gut microbiome.
Okay, and there's a big condition, isn't there?
A huge one. This probiotic potential really only applies if the kombucha is unpasteurized.
Heat kills the good stuff.
It does. Commercial kombucha that's shelf-stable at room temperature has likely been pasteurized, meaning those live cultures are gone. So you lose that specific benefit.
What about other claims? Antioxidants? Detox?
Fermentation does seem to boost antioxidant levels compared to the original tea. Things like polyphenols, vitamin C, green tea bases seem particularly good for this.
Okay.
And there's a specific compound often mentioned,
Here?
DSL, desaccharonic acid, 1-vorgolactone.
DSL, right. What's the deal with that?
Some research suggests it might be involved in detoxification processes in the body. It's something produced during fermentation that you wouldn't find in plain tea. So it's often highlighted as a unique potential benefit of kombucha.
So probiotics, if unpasteurized, antioxidants, maybe this DSL thing. Sounds promising. Is it a miracle drink then?
And that's where we need to pump the brakes. The source is very clear on this. Most of these exciting findings about antimicrobial effects, anti-inflammatory properties, antioxidants, they come from studies done in vitro, in test tubes, or on animals.
Not in actual people drinking it every day.
Largely, no. There's a real lack of high-quality, large-scale human clinical trials confirming these benefits translate directly to humans in a significant way. So calling it a miracle cure, well, the source says promising miracles would be definitely exaggerated.
Okay, so potential shown in the lab, but we need to be realistic about proven effects in daily life. Manage expectations.
Precisely. Now let's flip to the risks, because they're important, especially for homebrewers. Beyond exploding bottles.
What's the main worry?
Hygiene. Number one, hands down. If you're not meticulously clean jars, clean hands, clean cloths, you risk contamination.
Bad bacteria. Mold.
Exactly. Pathogenic bacteria or molds can get in. Drinking contaminated kombucha can cause pretty nasty digestive upset, nausea, and in very rare serious cases, things like liver damage or a condition called lactic acidosis have been reported.
So cleanliness isn't just suggested, it's absolutely critical.
It's the cornerstone of safe home brewing.
And the container matters here too, right? You mentioned avoiding certain materials earlier.
Yes. That links back to the acidity. There was that documented case of lead poisoning because someone brewed kombucha in a ceramic pot with improper lead-containing glaze.
Wow. The acid actually pulled the lead out.
It leached it out. It's a stark warning. Stick to glass. High-quality food-grade stainless steel might be okay for some parts, but glass is generally the safest bet for fermentation.
Okay. What about alcohol? We know yeast makes it.
Good point. Commercial kombucha is regulated, usually kept below 0.5% alcohol by volume to be sold as non-alcoholic. But homebrew, it's unpredictable.
It could end up higher.
Easily. Depending on sugar, time, temperature, your F1 could creep up to 1%, 2%, maybe even more in some conditions. So if you need to avoid alcohol completely, homebrew might not be suitable.
And are there groups who should maybe avoid it altogether?
Generally, yeah. Due to the contamination risks and the variable alcohol, it's usually not recommended for people with severely weakened immune systems, those with kidney disease, or for pregnant or breastfeeding women. Just too many variables and potential risks.
Okay. So for a healthy adult, being super careful with hygiene, what's a reasonable amount to drink?
Moderation is key. The sources suggest around 120 milliliters, that's about half a cup per day, is a generally accepted safe amount for healthy adults.
So enjoy it, but don't overdo it. And clean everything.
That's the mantra. Strict hygiene and common sense.
Wow. This has been quite the journey from yeast and bacteria to potential health benefits and exploding bottles. It really is a mix of science and kitchen alchemy.
It truly is. Homebrewing offers amazing cost savings and creative freedom, but it demands patience, attention to detail, and yeah, that absolute commitment to cleanliness.
The reward being this unique fizzy drink that might have some benefits as long as we're realistic.
Exactly. Keep the science in perspective. Keep the process safe.
Now, before we wrap up, Let's circle back to those SOBY hotels, all those extra layers piling up. Is there anything else you can do with that biomass besides just making more tea?
Ah, that's where things get really interesting, kind of next level.
Yep.
People are experimenting with the SCOBI material itself.
Using the pancake thing?
For what?
For food,
Hmm.
potentially. Some try drying it, candying it like a gummy. Others are exploring processing that protein-rich material into, like, vegan meat substitutes.
Seriously, like Escoti jerky.
Sort of. And it goes beyond food, too. The material itself, that microbial cellulose the SCOBI creates,
Yeah.
it has this unique structure, kind of tough and flexible. People are actively researching using it to create leather-like materials, sustainable textiles. No way! So the thing floating in our tea jar could end up as a handbag or shoes.
Potentially. The research is ongoing, but it points to uses far beyond beverages, from food tech to material science.
That's fascinating. So this simple symbiotic colony we use for a drink, its potential might reach much further than we think.
It really makes you wonder, doesn't it?
It certainly does. How far does the potential of this symbiotic colony reach? Something for all of you to think about and maybe research further. Thanks for diving deep with us today.
It was a pleasure. Until next time.